and thank you everyone for joining us. Let me quickly bring up some content, get the ball rolling. Perfect. Hopefully you're able to see my screen. Guys, Phil and I, we are really excited to share with you this journey we have undertaken at the Commonwealth Bank of Australia to deeply integrate H2O's AI capability with our decisioning ecosystem. But before we do that, I would like to tell you a bit about who we are. Commonwealth Bank of Australia, CBA, is one of the largest organizations in Australia by market cap. And 1 in 3 Australians call CBA their main financial institution, or MFI. Last year, we in fact finished #1 in consumer, business, and institutional banking Net Promoter Score, or NPS, among all the major banks in Australia. We are a business with more than 16 million customers, 800,000 shareholders, and over 48,000 employees. We offer a full range of financial services to help all Australians build and manage their finances. And today I'm going to tell you about a strategic program in the bank around hyper-personalizing next best actions, or what we call as next best conversations, or NBCs, for our customers through the use of AI. Let's get started. Now, as they say, everything begins with an idea. Let me take you to the origin of this program, first of all, in terms of how it got originated. Now, in CBA, we have something we call as Customer Engagement Engine, or CEE, which is our decisioning hub. The engine, this massive engine, interacts with millions of customers across 18 channels and runs over 450 models in real time to make around 50 million decisions every day. Now, you may wonder, what are these decisions? Well, to put it simply, these are over 600 different campaigns or proactive needs-based conversations with our customers. You can imagine the variety as well as the scale we are talking about here. And naturally, this engine was and is enabled with adequate science, business rules, and adaptive models to personalize these conversations. However, the question staring at us was, how do we make it future-proof? How do we inject more experimentation in it to really understand the types of conversations we could and should have with our customers? We also knew that coming to decision science, modeling may be the answer to that question, especially propensity modeling. However, modeling at this scale required almost unlimited resource and several years to make all of our campaigns truly personalized. So essentially, we were thinking about 3 key principles, or 3 pillars of the program, if I can call it: people, capability, and customer. People first. What was the challenge? Well, very clear challenge. We could not rely upon our army of decision scientists or data scientists, which meant that we had to come up with some kind of modeling labs or academy internally to upskill our analysts in H2O, or to be more precise, the driverless AI module of H2O. Done the right way, we knew this will also bring analytics closer to rest of the organization, as these analysts in CBA work hand in glove with our business or product teams. So that's the people pillar that got us thinking. Next was capability. We knew we had to hyper-personalize our customer conversations, but what does that mean? Well, to put it very simply, we knew that we had to go beyond the construct of segmentation or cohorts of any kind and really try to understand each and every customer individually. We had to leverage our campaign response data from the past and machine learning capability to deeply understand every customer interaction with the bank. And finally, the third pillar, which was the end goal, the customer. How do we identify the customers who need that conversation, that NBC the most, and hence are highly likely to give us a thumbs up when we reach out to them? How do we measure it the best way? By establishing the right control group, which in our case was not the cohort excluded from the conversation, but it was the one which was previously receiving the conversation, just that it was not a part of the model or the model output. So 3 things to bear in mind when we were hitting the sketchboard for this: people, capability, and customer. Now, let me bring this to life for you in terms of how some of our first use cases were engineered in terms of a before and after scenario. Now, imagine on the left, as you see, an NBC or a next best conversation or a campaign with three different segments driven by a variety of business rules. Let's take an example. Say I'm a bank and I wanted to talk to you about government rebates or benefits that government is giving you to avail, especially during COVID times. Let's think about who's eligible. Well, broadly speaking, if you haven't received this NBC in the past, and if you belong to a certain demographic and have a certain set of products, the engine sends out the campaign to you. The engine sends out the NBC to you. And as you will notice in segments 1, 2, and 3, 1 out of 3 customers like it and respond well to the NBC. They proceed with making that claim to the respective rebate. All in all, a good customer outcome. So what's the after scenario? What really changed with H2O? Well, here we tried to experiment in the NBC through an H2O model and study the customer response data of last 12 months for this particular NBC to predict what kind of customers respond positively to such a conversation. We overlay that learning then on the eligible customers of today to create that blue segment that you see on screen. And we score that segment at the customer level rather than at the segment level or the NBC level. Phil will tell you more on this vital scoring aspect that I just mentioned. But guess what happens when we launch this NBC to customers? 2 out of 3 customers in the H2O segment like it and make a claim for the rebate. That's double the number of customer outcomes than before. Or if I can say 100% uplift when compared with any of the orange segments there, segment 1, 2, or 3. Now that was a game changer insight that our first use cases told us. And imagine all of this while keeping the existing eligibility, channels, and creatives in place for that NBC. And all of this delivered end-to-end within 3 to 4 weeks, from model development to campaign optimization and go live. A process which would otherwise take 3 to 4 months, if not more. So what I just told you as an illustration is an actual NBC in the bank or an actual product, which we fondly call as Benefits Finder, the center tile that you see on the screen. Now, this particular NBC saw 125% uplift through the H2O model. I just told you how. That's 125% more customers getting aware of the rebates and benefits through this NBC and proceeding to make a claim which could help them during difficult times. Benefits Finder, in fact, has connected personal and business customers to $1 billion worth of grants, rebates, and concessions since this CBA digital tool was launched 4 years ago. Let's look at some other results. Expanding further on it from our first use cases, on the right, you see something called as Bill Sense NBC, which basically predicts your future bills and helps you manage regular payments and bills. So a personal finance tool there in the app for you, all of it in one place. For Bill Sense, we saw 168% uplift in the number of customers signing up for this great feature when we tried it through H2O. And finally, on the left, we thought, let's increase the variety of experimentation and talk about savings habits. We have a brilliant example there of how a very little initiative could encourage savings habits in our transaction account customers. We saw 102% uplift in new savings accounts getting opened. And guess what? These were customers who never had one. In fact, they had idle funds in their everyday accounts which were not getting appreciated in value in any way. So with these 3 early use cases and triple-digit uplifts that we witnessed, the question was, what next? What are we doing next in terms of these and other NBCs? Well, we are currently working in an agile way with our business partners We are scaling up these blue H2O segments that you saw on the previous slide to more and more customers until we start witnessing diminishing returns or response from the customers. And not just these three, a dozen more NBCs or a dozen more H2O models from different lines of business in the bank are being modeled in H2O, in Driverless AI module as we speak, and being modeled by our analysts. Finally, to the people aspect of this program. And I think with any strategic program having such smashing results, we need people who truly believe in it and collaborate with each other to make it happen. The people aspect, in fact, is easily my favorite one in this program, where we literally gamified the art of modeling among our analysts and decision scientists. We told them, hey, you are not building propensity models. You are building superheroes who are going to compete with each other every day for that better customer response. So we had a Captain America, or the benefits finder model, leading the charts in week 1, while Thor, the Bill Sense model, beating him hands down in week 2. And an Iron Man starting with smashing results in week 1 and 2, but then dipping in week 3, telling us that, hey, this calls for rescoring the model. So a lot of such insights in a gamified manner in terms of what our analysts shared with us. But besides the fun element, what this has done is it has created a community of learners in the bank across geographies who are asking questions and getting answers from each other in real time through group chats or discussion boards. These mates, if I can call them, and their superheroes exist in a proud universe in CBA we call as Superverse. I will now hand it over to Phil to zoom in on the game changer modeling platform of this program, the Driverless AI module of H2O. Thank you.
Thanks, Abhinav. Great to hear the value that you can drive using automated ML tools. So I'm just going to share just a couple of slides as well, and just bring to life who H2O is as a company, where we've come from, and then also the product stack that we have that enable these results to be achieved. Okay. So some of you might not be aware of who H2O is. So there was just a bit of a slide to give you a brief of a company overview. So we're a Series E startup founded in 2012, based out of Silicon Valley. There's a few key callouts that exist on this slide. Maybe I'll just go from left to right, and that is the people that we have and the companies that we serve on the left. So we're sort of very proud to call H2O the home of 33 cable grandmasters. Currently, we've got the world's number 1, 2, 5, and 9 working for us. And the reason why that's an important factor for us, and why we try to retain the best data science talent in the world, is that these individuals are working to win and lead the toughest data science competitions that exist out there in the wild. And what we do is we take their ways of working and we codify it and we embed that into our products. So that means that our customers, they get access to the best data science talent in a tool-based manner, and it's fully codified for them. So they don't need to be the world's best data scientists to have the world's best data science skills at their fingertips. The other key call out is that we're founded out of open source. So we have a really large community and also company support that sits under that as well. So we have over 200,000 company-based users of our open source product. And that's something that's very strong to us, to our ethos as a company as well. And then on the right, you can just see it's a bit of a US centric sort of viewpoint, but it's pretty much replicated in APAC as well. We have really strong support across main verticals of insurance and banking, plus also manufacturing and also healthcare as well. So what you would have seen on the previous slide is that we're looking at trying to democratize AI for organizations. And some of the key challenges that we see when we're talking to customers and they're trying to deliver data science solution is there's three key areas that they always run into problems, and that is in the talent, time, or trust. So in the talent sphere, we often see that it's very hard for businesses to be able to hire and retain the right amount of talent that they need to be able to deliver their data science solutions. I think if anyone on the call is a hiring manager, you know what tough competition it is out there for the talent that does exist. I think you'll see numerous articles that come out every other week about the chronic skill shortage that we do have. And this is extremely apparent in the data science and ML and data sphere. And so what we're trying to do is we're trying to enable customers to scale and deliver their data science solution at an enterprise-wide scale without the need for adding extra and a large amount of headcount on either the data science side or the MLOps, DevOps side as well. And how we do that is through our automated ML tool called Driverless AI, and also our broader AI cloud platform that I'll sort of covering in some later slides. So that sort of covers the talent side of things. The other one is time. I think a lot of companies are stuck in something that I like to call POC purgatory, and that just means they're trying to kick off these small use cases. They're building models, they're iterating, but they're never really actually seeing an enterprise-wide adoption of machine learning solutions. And they're not impacting their customers and delighting them like you've seen with all the MVC work that's been going on with Avanav's team. And so what we're trying to do is we're trying to reduce the amount of time that it takes to do the iteration, to do model builds, to get results that are actually business acceptable, to be able to put in production, and also enable you to leverage the best compute that's out there available. So if you're doing a natural language processing problem, having access to a platform that's GPU enabled, has AutoML built in, so that you can then build features off text and deliver that in a rapid amount of time, rather than having to configure everything yourself and building it manually. And the last one is probably almost the most important in all of the model build stage is trust. And so that's explainable using explainable AI to get a really good understanding of the decisions that are being made by your machine learning models, and ensuring that they're meeting requirements in terms of bias and fairness, and the actions that you're taking based upon those models, because they're having real impact on your customers, ensuring that they are fair and they are explainable. And then the last bit is being able to actually explain this to a business stakeholder, having the tools and techniques available at a click of a button, rather than having to go and manually create these in a code base, and having them visualized in a tool that a stakeholder can interact with, that you can explain to a stakeholder, really just helps shorten the whole machine learning lifecycle, and enables you to deliver results and get into production a lot faster. So I'll just cover off, I know I mentioned Driverless AI and Avanav as well. I'll just cover off what that is and the key componentry that sits in it. And then I'll just sort of explain the overarching AI cloud platform that we have, and then we can move to the Q&A section. So for those that aren't aware, Driverless AI is our flagship AutoML software. It's currently #1 Gartner ranked tooling that is out there. And there's a few key componentry that exist. One is obviously just connecting to data. There's over 200 data connectors available. You can join data inside Driverless AI. You can connect it to any normal object store that exists. But in the second stage, we've got something that's really important for data scientists, and that's the automatic visualization, and also data EDA that exists straight out of the box. And that enables you to ensure that the data that you're using is machine learning ready, We'll automatically detect, outliers, missing data. We'll do correlations. You can get a really, really robust understanding of the data set that you're working with in a really rapid amount of time, and not have to do all this your own custom tooling EDA in your own code base. And you get nice, easy to view and interact with visualization straight out of the box. And once you move past that stage and you're actually ready to start building models, there's two key things that exist in Driverless AI that really separate it from its peers. And the first one is really advanced feature engineering. So we have something that we call recipes, which is basically a feature engineering, which is, for those that aren't data science savvy, is taking data attributes and finding relationships between the two against the target of what you're trying to predict. So when we're running through this feature evolution stage, we can take a data set that may have 3 existing features that describe a customer, and we'll build potentially thousands of features from there. The other one that we have is also inbuilt NLP transformer-based architecture, and image and time series as well. So there isn't a problem that Driverless AI can't solve in an automated fashion. And that really advanced feature engineering step is the thing that gives us these really large business performance metric increases. So like Avinav was showing, 120% uplift off existing models. That's really the power of Driverless AI, which is really advanced feature engineering. And then moving past that is onto the parameter tuning and model ensembling. So combining a lot of really advanced models together with optimal parameters with really advanced features gives us this really big business uplift. And that's the key componentry that we see a lot of businesses getting a lot of uplift from, all in automated fashion, which means it's all scalable as well. And then the last two is it's a fully augmentable platform as well. So you can bring your own algorithms and transformers and anything else that you want in there as well. And then lastly is being able to deploy this. We're really flexible in how we'll deploy it. We've got something that's called a Mojo. Basically, it's just a Java object, and you can put that anywhere and score anywhere. So you can do in-database scoring, or we can deploy it on our own MLOps as an API. And the key to call out is this is extremely low latency and optimized to serve at scale. So billions of predictions in a short amount of time isn't a problem for Driverless AI. So when I've talked about Driverless AI, I'll just spend 2 minutes on this slide just to make everyone aware that Driverless AI is just a tool that exists within our product suite. We do have an overarching product that's called AI Cloud. We split this product into 3 main categories, being make, operate, and innovate. And I'll just cover what's in the make category quickly before we move on to Q&A. In make, you've got two main building for building objects called H2O3 or Driverless AI. We've covered those. H2O3 is open source, so more code base. Driverless AI is AutoML. And then we have something called Hydrogen Torch. Now, Hydrogen Torch is probably more bleeding edge than H2O3 or Driverless AI, which are good at more traditional tabular-based data sets. Hydrogen Torch is a no-code deep learning platform. So anything like image segmentation, image classification, object detection, language models, like question answering, anything that around NLP, and then also audio as well. So we can actually take in audio. We can classify what the call was about. Those types of use cases all fit into Hydrogen Torch. We also have Document AI, so that's intelligent document understanding. So being able to extract and classify information from manual documents, or also classify the document into a category, can all be done in Document AI. And then we have H2OA, which is a front-end application building framework. So that can be either done in Python or R and enables you to build website-ready applications in a low-code manner. And then lastly, we have AI notebooks. And so that's a hosted Jupyter Lab instance, which enables you to orchestrate anything within the make category, all through APIs, all within the same environment. And then moving over to operate, we have a feature store. So feature store means enables you to easily share data attributes between use cases and between users so that you can more rapidly scale how you're building models. The easy example, I think, is if you're doing a customer churn use case, that you have a lot of attributes to describe a customer. If you then want to do a customer pricing use case, you'll find that about 60% of the attributes you're using for one use case relate really strongly to the other. Having those available to you on a feature store enables the easily sharing between teams and between users to build your ML solutions in a more speedier manner. And then we have MLOps. So basically taking anything that you've built in the make category and actually deploying that as an API, hosting it, and having the monitoring on top as well. So you can score in real time or in batches as well. And then lastly, just on the Innovate side, is the App Store. So anything that you've built in Wave, you can then host that on the App Store, make that available to any of your business end users so you can actually start driving and visualizing real business outcomes. So hopefully that just gives everyone a bit of an overview of the full product suite that exists within AI Cloud. And then just to finish up, I know we're bang on time to move on to Q&A, but there is H2O World India is running on the 19th of April. We have a really strong contingent from CBA actually presenting at the workshop. So you see a few names in front of you at the moment. So we've got Andrew McMullen, Dan German, just as a call out a couple. They're actually giving talks at H2O World India. We also have speakers from AT&T and Eco Tokyo, as well as a few other banks. So I would encourage you to register for that. It's going to be online as well. So obviously, if you're not India based, you can watch online as well. Okay, I think we're about time for the presentation side. Maybe we can move to Q&A.
Thanks, Bill. Thanks, Avinav. Yes, perfect timing. So we will start with the Q&A. We've got a few questions submitted, so I'm just gonna read out the first one. Looks like this question is more for Avinav. So is the ultimate aim of features such as savings habits, bill sense, and benefits finder to reduce customer churn? If so, do you see the uptick in feature usage actually reducing churn?
Super. Thanks, Oksana, and thanks, Barrett, for that brilliant question. In fact, let me answer it this way. Each of those use cases that we discussed, benefits finder, bill sense, savings, they are driven by specific customer outcomes individually. So benefits finder, for example, we are trying to help customers connect to the right rebate or benefits offered by the government so that they can be helped during difficult times. And this was, in fact, a proposition developed in collaboration with Harvard University Star Labs. So the first intent or the primary outcome in mind is how do we take customers as deep as possible in that journey so that they can claim that rebate. Bill sense, again, in a likewise manner, we want customers to prevent paying any kind of fee or charges due to late bill payments and be more aware, be more on top of their bills. And similar for savings, how do you kind of see appreciation in value on your funds? Now, with that being the primary intent, with the intent being how do we help customers in moments that matter? Naturally, there could be an indirect outcome of it that those customers become customers for a lifetime with us, right? The churn reduces. And yes, more and more customers start calling CBA as their main financial institution. But is that the primary aim in mind? Probably not. The primary aim is the customer outcome associated with that particular NBC, and how do we kind of help customers in that regard? So that's on the first one. Hopefully that answers your question, Barrett.
Thanks, Avinav. Next one is, what existing technologies used at CBA has the H2O AI been compared to in terms of model uplift?
Sure. Happy to take a stab at that. Vinicius, thanks for that question again. I think there were two key aspects which emerged when we compared H2O.ai based models with the previous models, the propensity models that we had in the bank, or the uplift models that we had. One was data. So the richness of data that we were able to analyze through a driverless AI module was far greater than our previous models. So we talk about something called M360 in the bank, or a 360-degree view of a customer, helping understand the customer in multiple different ways and do it automatically through a model. So that scale of data, which we were able to crunch and absorb in a model for our customer base, that was notches up when it came to H2O.ai. And second was, as Bill mentioned, billions of predictions in a short amount of time. The turnaround time was phenomenal. I mean, we were developing models end to end within 2 weeks and taking them to governance to seek their sign-offs. In the past, this would have taken anything between 3, 6, 9 months to build an uplift model by a data scientist. So I think data and speed to market, those two were the key game changers when it came to comparing H2O.ai with some of the technologies that existed in the bank for modeling. But Phil, I'm happy for you to comment on this as well.
No, I think you covered it really well. Thanks, Abhinav.
Okay, super.
All right, moving on to the next one. How can you interpret the results of an uplift model? And what are some common pitfalls to avoid when interpreting these results? Phil, that might be more towards you to share some insights.
Yeah, absolutely. So yeah, there's a couple of key, without showing the tooling, there's a few key componentry that exists within Driverless AI. And there's a couple of things that we do. One is a lot of the features that we build for these models, because there's such advanced auto ML and auto feature engineering generation that occurs, is that often we lose sight of what a key feature actually means to a human, given that they're often a really complex combination of interactions between various features. So what we actually use is we have something called surrogate models. So we can use more simpler linear-based models that gives us an approximation of a really complex model. And that means we can enable us to pull out coefficients to show, you know, if we were to push a variable up by 1 point, what impact that would have on a customer's likelihood of using a service. And that just really helps us in terms of getting an understanding of the key drivers of the model to a human. And that's especially important when we're dealing with you know, business-based stakeholders. They're not interested in a prediction, they're interested in why a prediction, the key drivers behind a prediction. So if we're able to provide them those pieces of information, that's very key to getting them across the line. The machine learning driven solution.
Thanks, Phil. We've got one more question, but guys, feel free to submit any more questions that you want to get answered. So can driverless AI solve computer vision problems? Phil?
Yeah, so there is, you can do image-based classification within Driverless AI, but if you're looking at doing more deep, I think what I showed when we were covering the AI cloud, that we have a product called Hydrogen Torch. That's a lot more flexible. Driverless AI was more a tool built for tabular-based data sets, so really good at, you know, numeric data, categorical data, and just text-based data. You can do just image classification inside Driverless, but it's kind of retrofitted. The more optimal solution is to use the tool that was actually built for image classification, segmentation, object detection, all those really advanced use cases. That's Hydrogen Torch. So that's a better solution. And then the key to point out with Hydrogen Torch is that it's fully GPU enabled and also parallelized as well. So you can run multiple experiments and run async experiments across multiple GPUs. So it is largely scalable as well. But yeah, great question. Thanks.
Thanks, Phil. All right, so I think at the moment we don't have any more open questions, but yeah, feel free to submit if you still have any questions that are not have been answered. Just to share, we will share this recording of the session in the next couple of days, so you can also share it with your colleagues or refer to it after. And And yeah, thank you so much, everybody, for joining the session today. Hope it was insightful and useful. Feel free to reach out to us if you want any further details, or if you want a demo of the solution. And yeah, we hope to see you at the Digital World India as well. It's going to be streamed online, so feel free just to dial in and check out some of the talks there. So yeah, hope to see you guys on 19th of April, and thanks everybody for joining.
Thanks, Oksana. Thanks all.
Thank you all.
Thank you.
Great.